Well, welcome everyone to another CMC podcast. Today's subject is going to be rope rescue myths. And joining us today, we've got Wayne Chapman. Wayne, can you say hi and tell us a little bit about yourself?
Hey everybody, Wayne Chapman, current CMC Rescue School director, retired captain from Orange County Fire out in Southern California. Total of 33 years there.
Thanks, Wayne. John.
John McElmury, formerly the director of the CMC Rescue School, 46 years with Los Angeles County Sheriff's Montrose Search and Rescue Team as a wilderness rescue guy, as well as underground and confined space.
Thanks, John. Leroy.
Leroy Harbach. I am a senior instructor for the CMC Rescue School and retired from the city of Waukesha, where I was the master of nothing and the responsible for everything. So,
not a bad position to be in, right?
Yeah.
So. Yeah. And joining us today for his first podcast, Fred Salazar. Fred.
Hey, how you doing? Fred Salazar, senior instructor for CMC Rescue School. Currently, I'm a fire medic based out of Colorado. Been in it for about 30 years. Got both municipal and industrial background and been with CMC for about 25 years.
Excellent. Thanks, Fred, and welcome. My name is Doug McElmury. I'll be the moderator today. I'm a retired fire chief out of Pleasant Prairie, Wisconsin, and been involved in technical rescue now for about 37 years. And I'm a instructor for the CMC Rescue School. So we run into quite a few myths when we're, between teaching and looking at some of the feedback from some of the social media platforms that we use. And so we thought that would be a good thing to address in a podcast. So Leroy, why don't you start us out? One of the things we hear quite a bit are that when you have especially a screw gate carabiner in the vertical axis, you must always have it so the gate opening is at the bottom. What are your thoughts on that myth?
Yeah, it's something that we hear often that if carabiners are hanging in a vertical type of application, confined space or rope rescue system, or even horizontally for that matter, but typically vertically, is that the gates have to be screwed down because gravity is going to help hold it in place in the locked position. Truth of the matter is it comes down to the harmonics in the system. In other words, how fast are people pulling creates vibration in the rope. And what we see typically during the course of class, whether it be training or actual rescues, we've actually seen it happen on rescues, is that the gate actually, when you hit a specific harmonic, that gate is going to open and close all by itself. It'll screw itself open, screw itself closed, and it will continue to do that as long as that specific vibration is in the rope. So I would say, nope, doesn't really matter, because it certainly doesn't matter to the strength, and the carabiner doesn't care. So that's where I'm going to leave that for right now before I go off on, before I climb all the way on the horse, if you know what I mean.
Got it. So Wayne, what are your, anything that you want to add to that one?
Yeah, I agree with Leroy 100%. In fact, him and I have both personally seen this happen. We did a class down in Panama and actually saw this, and it occurred long enough that we were able to actually climb the tower, and Leroy was getting his phone out to shoot some video before the guys finally stopped hauling. I think rescuers and students need to be more concerned with how is the carabiner loaded versus gate up or gate down, right? Now, if you are truly worried about a gate coming unlocked, put it in manual lock or an auto lock carabiner. But you should be far more concerned with how you're loading that carabiner than you are gate up or gate down.
Excellent. John, what do you have on this one?
Well, one of the things is for someone, and it'll probably be another topic, is that the steel carabiners, the nuts tend to run a little easier, I think, than the aluminum carabiners. And if it's an aluminum carabiner, and we know they stretch, and it's a fairly substantial load, the load may keep the nut from running up and down. Or if it's an older carabiner, the nut may not spin as easily as it would on a new carabiner or perhaps a steel carabiner. But what Leroy said is still correct. It doesn't really matter. And I've seen them move. We use all aluminum, and I've seen them move around. So it can happen either way, but steel tends to spin easier, and that's where it might be more noticeable.
Excellent. So I think we pretty easily have disproved this myth here. So moving on, actually, kind of on the same topic of carabiners, we hear again and again that when you have two carabiners connected to the same thing, even locking carabiners, that the gates need to be opposite and opposed. So, John, do you want to take this one?
Well, yeah, I've never really heard about it as for locking carabiners. That was, to me, the reason for a locking carabiner. The origination of opposite and opposed came from the climbing world, where they traditionally used non-locking carabiners. And the concern was, well, I can turn around and load this carabiner in such a way that I'm going to either open the gate and lose my load somehow, or that I'm going to weaken the carabiner because the gate's essential for part of the load on it. And that was the theory behind, putting the carabiners on, spinning one, and then that way you had the solid spine of the carabiner up against the gate on either side, and you couldn't get anything out by accident. Obviously they came out with locking carabiners, which allowed you to just use a single carabiner and lock it and not have that concern. And then I think people, like they do in a lot of these subjects, carry one thing over to another without really knowing its history. And, if you want to use locking carabiners and you want to do opposite and opposed, which is really not necessary, I would suggest that you do spin them opposite opposed, because then the nuts aren't rubbing on each other and it's not a wider cross section, but it's not necessary with a locking carabiner.
And I think you just highlighted, too, one of the important things about a lot of these myths. They actually started out with some truth, but then they get carried into and well beyond where the truth actually was.
Hey, Doug, if I could add
Yes,
on to this topic in our previous one is with the gates, we talk about using manual lock gates, screw lock gates, auto lock gates. The auto lockers and manual lockers aren't the end all be all. Every carabiner design has its pros and cons. Well, like everybody else, I've seen screw lock gates open and close based on the harmonics of the system, whether it's on the end of the rope I'm hanging off of or in a Hall system. Putting in an auto locker may not be the end all be all, because that institutes a thought process of safety that may or may not be there, because I think we can all attest to seeing an auto locker being pulled across a rock, catching the collar, twisting over, and now you've opened and unlocked that gate. So, you got to look at the application and not get lulled in that false sense of security because it has an auto lock mechanism to it or something like that.
Yeah, and that makes sense. And none of the systems, none of the hardware is human proof. We need to keep our eyes and our ears open, and we constantly are telling people that they need to do good system checks prior to loading, and that includes looking at and touching the carabiners. And ironically, we've had a lot of. It's interesting you mention that, because we've had a lot of comments on the social media end of things where people thought that the carabiners were unlocked in the system. So many, in fact, we actually just released a what's wrong with that specific topic, and we also released a pro tip with that topic. So it may have been a fundamentals.
And to jump on that horse that Leroy was talking about, and I hate to throw this out here, Leroy's already grinning at me. Redundancy in a system. So opposite and opposed of locking carabiners. Well, in theory, it sounds really great. We're building in this redundancy. But the more stuff we add to the system, I think we can all attest to, we don't hear about a lot of equipment failures. What's the failure that we see most often? And you just hit it. They're not locking carabiners. So the more stuff we add, the more stuff we can miss. Hence, are we really adding any safety to the system?
Yeah. Well said. Well said. So,
Doug,
go ahead.
Doug, are you saying that you actually have to be smarter than the equipment?
Well, hopefully no stupider than the equipment, that's for sure. So, but yeah, it's amazing. We kind of joke around, but yeah, the weakest link in the entire system is the human in there, right? So, I mean, the equipment is so unbelievably strong. We're the human body will break much faster, but I think that also goes mentally. Yeah. And I think we're kind of breaching into a topic that could be a several episode podcast on with how humans interact with systems. So
I think that'd be great for Leroy to moderate.
Yeah.
Yeah, Doug, I think to wrap up this myth, and a lot of these guys have heard me say this 100 times. I'm a big never say never, never say always guy, right? Look at the situation and make a decision based on what's going on at that particular point. Don't ever say you always have to do this, and don't ever say you never have to do that, right? Situation dependent.
Yeah. Yeah, well put, because we have so many self-imposed rules that we try to make, trying to human-proof it. So, which is kind of where this next one came up, and that's how you load webbing into an offset D-carabiner. It's interesting, some of the myths that we've seen out there where the entire purpose of an offset D-carabiner is so you have a wider end to be able, if you have like a piece of 1-inch webbing, to be able to put that in to keep the load off of the gate. But yet, some people are adamant that the configuration of the carabiner needs to be a certain way in relationship to the anchor, with gate away or gate down or whatever, that they're actually putting the wider piece, like the 1-inch webbing, into the narrow end of the offset D, henceforth putting a bigger load on the gate instead of on the spine, and canceling out the safety that's actually built into it. So it's, that myth actually spits in the face of safety. So when we see that, we try to, tell people, just like Wayne said, you got to look at the situation, forget your kind of self-imposed rules, and look what is actually happening here, and where is the load, and what's going to weaken it. So, John, your thoughts?
Well, the reason originally for the offset gate was so that the gate would open wider. And I don't think, it could be wrong, but I don't think webbing was really what they had in mind when it came to loading it. But, that way you could make a gate that went around, say, a 1-inch litter rail or something like that, and didn't increase the overall size of the carabiner or the weight any. But it kind of got construed otherwise about how we're going to load it and everything like that. And you mentioned something about that gate up, gate down, and in a horizontal application, and we may come back to this on something else, whereas it's, say in a horizontal application, it doesn't matter if it's an offset D or a straight carabiner, with kind of an oval shape. It's usually the gate down is probably better, because then gravity is going to keep the load onto the spine of the D carabiner. But most of the time, people will load it the opposite way, because that way they can see the gate. And I like seeing the gate, especially when it's me connecting the rope from my harness. But, the offset or regular D carabiner, the gate down on a horizontal is really stronger, but you rarely see it that way.
Yeah, and I think some of that too, whether you're in a natural environment with, the snow, ice, rock, or whatever, or in an industrial environment where you have like roof ballast or debris or like grading that can catch that gate, I think that in a lot of times will prevent people from wanting to put the gate down. But I agree, it makes a lot more sense to have the gate down. Gravity works, right?
Yeah, gravity puts it on the stronger part of the carabiner, but I agree, you don't want it in the muck, the roof, the abrasion, or just because you want to be able to see easily that the gate is locked. So it's, there's no right or wrong on it. It's like, here's the reason why it's stronger this way, but it's better maybe to have it the other way. And then it comes down to, as several of us have said already, stuff isn't breaking. There's misapplications of gear, and certainly the carabiner is stronger along the spine than in the weak direction. But we're not seeing a problem with carabiners breaking. So
yeah, if anybody's ever watched a carabiner test and you see the volume of force that it takes, you realize pretty quickly that the human body could never tolerate anywhere near that.
And I think this kind of ties into the previous myth of gate up, gate down. I know Wayne and I have had this conversation. You're putting an offset D through interlocking bowlines or webbing, and how is that load, how much real estate is it taking up inside that carabiner is it truly going to shift to the spine, or is it going to shift towards the gate, which is the weaker end? So now I think we have two myths that are kind of coming into contact with each other, and one promulgates the other.
Yeah, exactly. So, which actually kind of leads us into to another myth involving carabiners. Fred will kind of throw you in the pool on this one here. We hear all the time about metal on metal. So what are your thoughts on that myth?
If we could build a system where we don't have metal on metal somewhere, I would love to see that, because if you're using an anchor strap, you have metal on metal. If you're connecting to a litter, you're probably putting a carabiner on a litter rail or a strata load, unless you're doing like a plain straight cordage or webbing bridle. There's always going to be contact somewhere. Carabiner on a pulley. So, back in the day, and the day was when John and Leroy started, metal was a lot different. Metallurgy's come a long way. I mean, when I started in the early 90s, everything was steel. Now we're using aluminum, and we have aluminum that's just as strong as steel. So the metallurgy's changed quite a bit. So I don't think we're seeing the same issues we did back when this myth started.
Yeah, John, your thoughts?
Yeah, back again to either being an old guy or not really coming from a climbing background, but coming from a wilderness environment. The metal on metal thing came from the climbing world, with the idea of chaining carabiners when people were using artificial protection and, using a piton or something like that. When you had a chain of carabiners, you were twisting the carabiners, and the concern was with a carabiner up against a rock and it didn't have a soft link in it of some kind, that movement of the rope and everything through there would tend to wedge the pin out or damage the hardware. And that's really kind of where it came from. And then where it was metal on metal for your climbing anchor. And then it kind of as more, because the rescue techniques we're using in public safety rescue all came from climbing and caving, and it kind of progressed over about no metal on metal. And as Fred said, there's just impossible not to build systems without metal on metal. Obviously not all the harnesses have a metal front ring. If you're a climber, you may go rope to rope, but somewhere you're going to find some hardware in there in a public safety rescue system where it's carabiner on a pulley or MPD on a carabiner to an anchor plate or whatever the heck it is. And you have to go back to the history and say, this is why they did it, because we didn't want to twist. Well, we're basically non-locking aluminum carabiners that weren't nearly as strong as they are today, and or pulling levering your anchors out and damaging the hardware. And it just was a good idea for that. It's still a good idea for that, but it gets carried on by people that just, all they know is metal on metal, and they never really thought about it.
And it's kind of interesting, some of the links that I've seen people go through to avoid the metal on metal. Probably one of the classics I saw was in a haul system. Somebody used the Gibbs as a haul cam. They then had a short piece of prusik cord tied in there to a carabiner, which then got connected to the pulley. So there was still metal on metal, but they used the short piece of prusik cord as kind of a, if you will, a soft swivel. Ironically, they used the ascender on the rope instead of just using a little bit longer piece of prusik cord, tying a prusik, putting a prusik hitch on there, and having a much stronger connection to the rope that would do the same thing. But I think a lot of the times, I'm sorry, go ahead.
No. I didn't mean to interrupt you. But at the same token, they still had metal on metal because that carabiner on the prusik was connected to a metal pulley.
Exactly. Yeah. And they actually had, they didn't. And this is, I think, one of those important things, kind of back to Leroy's comment. Do we have to be smarter than our hardware? Yeah, in this case, we do. I mean, they put a mechanical ascender on a rope that is actually capable of stripping the sheath or even cutting the rope at a critical point instead of using a prusik on there. So, and something that in that device specifically has been known to do that. So, why not solve the problem and use a prusik in that case? But I think a lot of times, there's such good test data out there, but maybe it's not getting out to the end users as much as it needs to. I know we've routinely talked on this in this forum about the presentations at both NADERS and IDERS. And for those of you who aren't familiar with NADERS, NADERS was the North American Technical Rescue Symposium, which is the predecessor to IDERS, if you will, the International Technical Rescue Symposium. And there's some phenomenal research that gets done, and some of it is very, very low tech, but it literally has revolutionized the rope rescue world over the years with what's been discovered in that.
So, Doug, there's almost a subset to this metal on metal, and maybe for the listeners, and I'm certainly don't have the background for it, but when some people hear metal on metal, they think about dissimilar metal corrosion.
Oh, good.
Right?
Yeah, between like stainless and
storage of parts together, right? That can, you have to have the proper, right? You have to have the two different types of metals with some sort of electrolyte. But maybe some of our listeners might be thinking that that's what we're trying to discuss. Another whole subset, right? But we have come across gear over the years. We've seen where people have stored dissimilar metals together, and the outcome isn't good over the long term.
Yeah.
Obviously, a place for a lot more testing.
Yeah. Luckily, in a short term, like during a rescue, we're not going to have that problem.
You're not going to have that during a rescue, but if you have people that store dissimilar metals together for long periods of time, it's certainly a possibility.
Excellent. And I think two other things that, where the metal on metal thing, they're worried about the twisting, like in that Hall system example I gave, they were worried about the twisting of the pulley, the carabiner, and the Hall cam. And so, swivel different. There's multiple manufacturers of swivel pulleys, and has definitely solved that problem in many ways. So I think we've kind of beat carabiners and some of this stuff here to death here. Why don't we kind of dive a little deeper here? Every once in a while, you'll hear somebody that is pretty dedicated to, or is adamant about staying with a dedicated main, dedicated belay, doesn't want to use TTRS because of edge transitions. So Wayne, do you want to take this one?
Yeah, and again, I think we need to divide this into two separate categories, right? You obviously have the people that believe in one or the other, and that's not what I'm talking about. Are we talking about a training class, or are we talking about an agency-specific policy, right? So some fascinating articles have been written over the years, some by Kirk Mothner, another one by Mike Gibbs, that talk about this. Obviously, the downfalls of a twin tension system for that very short transition is the fact that you are defeating the safety mechanism of one of your ropes. So let's say you're using two MPDs or two clutches. Right? When you make that transition, you are holding the handle open. Right? If something happens, you have to physically let go. Whereas if you were to lock one of the devices and make a transition with just one device, the second one is locked and hands off, right? So you've not defeated the mechanism, and the guy on the sole device has a much better feedback of the movement of the load, right? Mike's article really gets into this, where if Leroy and I are sending a litter over the side, a loaded litter, right? Who owns the load, right? We're constantly playing off each other, right? The load goes down through my rope to the litter and back at the Leroy's rope. We're constantly going off each other. Whereas if I own the load for that very small, 1 meter transition, I own it for that split second. Once the load's over the side, we transition back to twin tension. I'm not saying one way or the other is better, but in a class of students who have never met each other, that can be certainly much more dangerous than in a department where the same team works together all the time, and it can easily, make that transition. Obviously, testing has shown on a sharp edge that two tension ropes are certainly better off than one, right? And Mike's article points to the fact that, well, if that's such a problem, put more padding in or pick a different edge if you can, right? So again, I think it goes back to, are you talking about a training class, or are you talking about agency specific? Because they both have their merits and they both have their downfalls.
Okay, Leroy, any thoughts?
No, I agree with Wayne. I know in training classes, we essentially try and get guys to pre-measure that belay, and I'll refer to it as a belay in a twin tension. That second line, pre-measure it to the edge, and then take that device, lock it off, and essentially, you can't really say take it out of service, but the operator's not operating it anymore. and one line controlling that load going off over the edge. Number one, it's cleaner, and it's certainly easier for people to see the advantages and or disadvantages, because we do it both ways in class, so that people get a better understanding of edge transitions can be interesting. And we don't like interesting edge transitions. You know, we want to try and make it as boring as possible. And so whether they do it with a dedicated main, dedicated belay, or two ropes under tension, the twin tension system, really comes down to, like Wayne said, in a training class, it's one thing, but a team that works together, you got to make a choice. What are you doing? And you base it on education and knowledge and what you've experienced before, and make your decisions based on that.
Okay. Fred.
Well, I take a little bit of a different view between dedicated main and belay versus twin tension is you got to look at your scenario. So I have a background in an industrial setting. So if I'm coming off of a deck and I got a bomber-proof I-beam above me, can I run both of my lines through a high point direction that's bomber? They're independent. Then I can run a twin tension system. And I feel pretty secure with that. Or am I going over a handrail where one line's going over the handrail and one line's going under the handrail in case the handrail fails? Well, then we have to switch to our dedicated main and our dedicated belay and then transition into a twin tension. Or am I using something like an Arizona Vortex where, hey, this is an artificial high directional, is there a chance that it could fail if I run both of them through the high directional? Or am I using a saddle of a tree branch for my high directional? So I think you need to have a little bit more of a technical eye when you look at how you're going to apply these. And Wayne said it early on. If you say always and never, you're going to paint yourself into a corner, because there's so many variables that we can look at to cause us to adjust the way we run our systems.
Yeah, I agree. That's no matter what system you use, you have to be competent at that system. So, John.
It's kind of funny, Fred's point about high directional over a fixed beam or some sort of other bomber anchor is definitely something that usually doesn't come up when we're talking about this subject. Most of the time, the concern is something like a vortex or something where there is some possibilities of instability, and that's where it usually comes down on what you're going to do one way or another. And I guess it comes down to the statement that Wayne said earlier, that everybody has to know what they're doing on it and realize that there's, something's going to happen. Taking a loaded litter over an edge, a square edge, is probably the hardest thing there is to do physically. And obviously the high directional makes that easier. And if you're going to lose the high directional, then, you want to have the belay still in place. Most of the time, we try not to do it with a loaded litter. We show different techniques for climbing into the litter on square edges and things like that. But there, it's not really an issue, because the load's there. It's always loaded. It's somebody with a basket going over the edge with a high directional type of thing, and the risk of losing it. And I think it's easier to manage, especially for people that don't do it all the time. And hopefully none of us is doing that all the time, except in training environments, that I think they're better off with not having the twin tension system. The rigging is for twin tension, but the operational for that short moment and that meter or two of rope is going to be loaded main slack belay.
And I think that makes sense. One of our other podcasts, we talked specifically about training, basically twin tension versus dedicated main, dedicated belay, and competencies, especially for teams that don't have the opportunity to train very much, just due to, other things, especially like in the fire service and so on. So what's everyone else's thoughts about which of the techniques with TTRS is easier to teach, try to maintain a load on both, or trying to, as you say, isolate one, somebody else owns that load. So Leroy, any thoughts on which is easier to teach and I should say, and maintain competency?
Oh man, competency is a podcast in and of itself. Because what does that word mean? Competency on that particular day, or competency 2 weeks after training is over, and it does come down to muscle memory and everything else. Personally, I think that you need to have a variety of tools in your toolbox. Like Fred mentioned, every situation, depending on your response parameters, what does your response district look like? Am I totally a wilderness guy, or do I've got that urban interface, if you will, or do I have an industrial response and a USAR type response, which could be any one of a number of things. So I think you really need, is it easier to teach twin tension systems where everything in the system is exactly the same as the other thing? In some ways, yes, and in some ways, no. It can be a little gear challenging or equipment challenging in certain situations. And organizationally, it does come down to individual organizations. But I think you need to have a whole bunch of tools in your toolbox and apply them appropriately based on your knowledge base, based on what those situational things call for. So you can't just say, yep, it's easy to teach this one, or it's really hard to teach this one. Everything, if I'm in a CAN training tower and that's the only place I ever trained, yeah, you can come up with a technique that, yep, that's where it is. But as soon as you take it out to the street, does it work? You don't know until you take it to the street. That's why you got to have a bunch of tools in the toolbox.
And be competent with those tools you have in there.
Right.
Yeah. So I know, Wayne, you've kind of mentioned a couple of times, especially like in the industrial setting, where you're the fortunate thing you have is like the inside the fence situation, if you will, as compared to like the fire service or like say some of the multidiscipline teams. So how do you think that any other thoughts on that those two kind of very diverse groups fit into this?
Well, and again, I think it just goes back to your background, right? I mean, Fred kind of nailed it. If you have, a piece of angle iron above your head, this is a non-issue, right? But if, on the other hand, if you are out in the backwoods somewhere and are trying to take a loaded litter over an edge, then it's different. Having done a lot of teaching at refineries and stuff, we try to bring the fire service in whenever we can, because most firefighters and, municipal guys, when they go inside of a refinery, what I call inside the fence, it's a whole different world. They don't really know what's going on. And conversely, the industrial guys, when they get outside, they're not used to just running, 10, 15 calls a day. So it's a very different world that they both have, and they both need to train in each other's world to understand where the other one is coming from, right? And it's a lot harder for the industrial guys to get off-site than it is for your typical fire department to be able to come into a refinery because of coverage reasons.
Okay. Fred, any thoughts on kind of that angle of things?
Well, and kind of tagging on to what Wayne was saying about inside the fence, coming from an industrial background, I worked for a large corporation that we were a dedicated fire department within the petrochemical facility. And then we had unit operators that were also trained that were our backup. Well, you could go to other facilities where you have 3 response people on at night and they're unit operators. So, the industrial setting may or may not have the backup that, a municipal agency has, where they can call another engine company, a truck company, a heavy rescue company, where, resources are kind of unlimited. You go to some of the Southern California agencies and they call in a camp crew of just some big old burly dudes, and everything is a 1-to-1 mechanical advantage because they got, 36 hunking dudes walking down the rope, pulling the rope. So, inside the fence, outside the world, the number of people you have can play a big role in that too. And like Wayne and everybody else is saying, you got to be competent in your skills, whatever that term competent means, but you also have to have a pretty big toolbox because it's very dynamic, both in the wilderness setting on how many people you get to respond, industrial setting, or with a fire service, depending on where you're at in the country and what's going on in your region as far as wildfires, floods, stuff like that.
Yeah, makes sense. John, what are your thoughts?
Well, it's something that probably everybody has said, and it comes back to the training environment. And one of the things that we've always tried to do is get people into multiple situations. And it's always unfortunate when we do classes for an agency and they want to do everything at their training tower and they don't want to do any real world environment. It doesn't matter if it's rope rescue or confined space rescue or whatever, but thinking about the things you say, and how many times have we done these classes where everybody is so dialed in that this goes there because they have all kinds of built-in anchors in their towers and everything like that. And then all of a sudden you take them out, and instead of tying to a big bolt or a screw shackle or whatever the heck the anchor is, and now all of a sudden you've got to look for trees, rocks, and bushes, or you put them into an industrial environment, and there's all kinds of heavy duty anchors there. In the industrial end, say petro or some part of the process industry, it's really, generally, it's easy to find anchors, and they're all substantial anchors, but it kind of puts people out of their comfort level. And, maybe it's a little off topic, but I just, can't emphasize enough that people need to get out of that same environment. I'm not going to frag a training tower because it's a great controlled environment in most cases. I mean, we've been to some pretty crappy towers. I'm not saying that, but they getting people out into the real world, that's their response area, is so important. And we see so many people that they want to be on the tower. That's where they are. That's what they're used to. That's where the training chief is, or whatever the thing is. And they don't have this desire or ability to get out and train in other places where, in fact, they might going to be responding. Like Fred says, you've got some petro operation that's got 2 or 3 operators at night. They're going to call for help, and those guys coming in need to train there. They need to pre-plan it, and they need to get used to that environment because it's so foreign to them. There's noises and smells that they're not used to if they don't go there and train. We've been fortunate. We've seen a lot of people to do that with, but I know there's a lot of them that don't. And I can't emphasize it enough to the listeners that they need to practice these things in more than one location, for sure.
And if I could tag on to John, it brings up a good point. A very good friend of ours that used to be one of our instructors on a well-known search and rescue team, they would have car over to the sides at a spot where it happened quite frequently, and they had a system set up to do the rescue in that area. Well, they go out there one day to do a rescue, and as the car went over the side, it took out their anchor. So the system they had set up no longer worked because it was kind of measured and stuff, and mysteriously the anchor is not there. Professional team, these guys were able to make the changes, but if you get kind of lulled into that, we do it the same way every time. If something changes, are you going to be able to recover?
Yeah, I think that's a really good point. And ironically, in my first 2 district, we had a very large power plant, and we traditionally had very, very few calls at that power plant. The employees knew it well. They did a nice job of running it. Where we ran into problems were when outside contractors came in that weren't as familiar with the facility. And that's generally where I think in most industry we do see problems, is we have people that aren't used to or familiar with the facility come in. And just like, John was saying, unfortunately, the people not familiar with the facility, maybe us, maybe the fire service coming in, with good intentions to help. But if we don't know the place, we could be more of the problem than the solution. So I think kind of starting to wrap things up here, most of these myths, not all, but most, started with some reality, whether it be, older equipment like you had talked about, if it was, like unlocked carabiners versus, or non-locking carabiners versus locking carabiners and so on, metallurgy and things like that. So many of these things started with some truth to it, but then unfortunately it got misapplied to the rope rescue or confined space rescue area. And I think it's so important that we keep up with, what's going on, the testing, and, if something doesn't make sense, is why a bad question to ask?
I think why is the question to ask every time. Whether you agree or disagree, it comes down to why. I mean, and I was always that guy, and I still am, well, you can't do this. Why? I saw this in a cartoon. I think I can make that work. It's if you ask why, even if I make up an answer, and I'm pretty famous for saying it, if I don't have an answer, I'll make one up. I generally don't. Well, usually don't. But I think why is the question. And that's what's led to a lot of those presentations at ITERs and NATERs and everything else, is somebody asking why. You can't do that. Why? Prove to me either why or why not. And I think that's kind of the crux of technical rescue in general. You told me why, but you didn't tell me why not. And firemen, responders, they're all cut from the same cloth. You said to do this way, but you didn't tell me not to do it that way. You know what I mean?
Mm-hmm. Well, I think
isn't the answer to why because we always did it that way?
Yeah.
Well,
yeah.
Ironically, too, some of these things, some of the new questions of why or why not coming up, the trade has evolved so far, and I know we've discussed it in other podcasts that there were presentations back in the 80s and 90s, even in NATERs, that address some of these issues that are just coming up as, and I'm using air quotes here, new problems. Well, no, that's been a problem forever, and there's been the people have looked at it but have kind of forgotten about some of the testing and some of the lessons learned from that. And I think that's so important. We learn those lessons and move on from them, right?
Preferably not the hard way.
Yeah, exactly. Yeah. So any other closing thoughts, Fred?
No, I mean, kind of Leroy hit the nail on the head. Always ask why. And if you don't have an answer, do your research. The rescue world is a pretty small family. Everybody seems to know everybody. It's like 7 degrees of Kevin Bacon. Find out an answer. And if you don't, reach out to CMC, to some of the instructors, and hey, maybe there'll be an ITERS presentation with your name on it.
There you go. John.
Well, I think as kind of an industrial safety trainer, if you will, or public safety trainer, for having done this for so long, that the important thing is that the people that do the training not just rotely repeat what they've heard from the person that did the training for them, that they get a little more of a background, just like that. The old time stories that we tell here about, well, this is why the metal on metal or don't chain in carabiners came about, or this is the reason why whatever it is came about, that the people go and they're doing the training, not be people that just learned it a couple of weeks before and that actually can give you an answer or can give you the history, or that are willing to take the time to do the research and do it. And that's what, as kind of being an old timer, you see these things going along. And it's like, do you really know what's going on here? And the people that are listening to this probably do, but look out there to the rest of them and say, how do we get this information to people so that they're not just repeating things monkey see, monkey do, and they don't really know the explanations behind it, especially when one of their students says why.
Leroy, anything else?
Well, I agree with John. We go to other people's classes. They come to ours. It's refreshing to go be a student for a while because it takes a little bit of pressure off, but it's a different way of solving essentially the same problems a lot of times. And maybe there's easier ways. You learn different techniques. You gain a little bit of background of different perspectives, and maybe they have a perspective that we haven't thought of. And I think that continuing education is something that never ends. So,
yeah, well said. Wayne, any closing thoughts?
Other than, like I said earlier, right? Never say never, never say always. As a rescuer, you should be much more concerned about how, what is going on with your gear versus, hey, I have to always do it this way or always do it that way. Look at the big picture. Stand back and say, okay, yeah, the gate's locking downward, but now the carabiner is grossly side-loaded. Or, hey, I'm in an industrial facility and I've got the gate down, and the gate is constantly hanging up on the metal grating, right? So, take a big picture approach to this stuff and ask yourself, am I backing myself into a corner with all these myths? And that's about it.
I heard a good saying one time. It was actually about a different field, but I think it applies well to this. If you put 10 rope geeks in a room, you'll hear 12 opinions on how to do it. And I think a lot of that is true here. But the important takeaway from that, I believe, is you have to look at what way works best for you with the makeup of your team. What areas do you cover? What resources do you have? How much training do you do? What kind of anchors do you? All the things you guys have all talked about, I think, all really play into making that good decision about what tools are going to work best in your toolbox for the area you're covering. So. Well, thanks everyone for joining in on this episode of a CMC podcast, and look forward to working with all of you in the next one.
Thanks, Doug.
Thanks.
Thanks.